What is blockchain? Blockchain is a decentralized and distributed ledger technology that allows multiple parties to have a single version of the truth without the need for a central authority. It is the underlying technology behind cryptocurrencies like Bitcoin but has applications beyond digital currencies. Key components. 1. Blocks. A blockchain consists of a series of data structures called blocks. Each block contains a list of transactions or other digital records. These transactions could involve anything from financial transactions, as in the case of cryptocurrencies, to the transfer of ownership of assets, supply chain information, or even voting records. 2. Decentralization. Unlike traditional centralized systems, like banks, blockchain is decentralized. No single entity has control over the entire blockchain network. The information is distributed across a network of computers, nodes, each maintaining its own copy of the blockchain. 3. Chain. Blocks are linked together in a chronological order to form a chain. Each block contains a reference hash to the previous block, creating a continuous, unbroken chain of blocks. 4. Consensus mechanism. To add a new block to the chain, there needs to be an agreement among the network participants. This is achieved through a consensus mechanism. Common consensus mechanisms include proof of work, used in Bitcoin, and proof of stake. These mechanisms ensure that all participants agree on the validity of transactions before they are added to the blockchain. How blockchain works. 1. Transaction initiation. A participant initiates a transaction. This could be a transfer of cryptocurrency, a change in ownership of a digital asset, or any other agreed-upon action. 2. Verification. The transaction is broadcast to the network. Nodes on the network validate the transaction's authenticity and check whether the sender has the authority to make the transaction. 3. Block creation. Once verified, the transaction is grouped with others to form a block. Miners or validators, depending on the consensus mechanism, compete to solve a complex mathematical problem to add the block to the blockchain. For consensus, the rest of the network verifies that the proposed block is valid. Consensus mechanisms ensure agreement among nodes about the validity of the block. 5. Block addition. Once a consensus is reached, the new block is added to the chain and the information is updated across the entire network. 6. Immutability. Each block contains a reference to the previous block hash, making it extremely difficult to alter any information retroactively. This immutability adds a layer of security and trust to the system. Use cases beyond cryptocurrencies. Blockchain's applications extend beyond cryptocurrencies. It is being explored for supply chain management, tracking the origin and journey of products. Smart contracts, self-executing contracts with the terms of the agreement directly written into code. Healthcare records, securing and sharing patient data. Voting systems, creating transparent and tamper-resistant voting systems. In essence, blockchain provides a tamper-resistant, transparent, and decentralized system for recording and verifying transactions, fostering trust in a wide array of applications.